Hello, thank you for joining us for this session from Dockerfail to Dockerfile. I'm with my friend Mohammed. Mohammed is working at Spotify as a senior backend engineer, and I'm doing some consultancy about DevOps and everything containers and Kubernetes. Mohammed?
I like the way how you just introduced me. Thank you. So, by the way, this is a 40 minutes talk, and Jalal is quite stressed about the 30 minutes slot that we got, so just like he was just running and rushing all the way. So just chill, man, it's gonna be fine. So the talk is titled From Dockerfail to Dockerfile. It's basically highlight the things that we run through while working with containers and Docker, mainly Docker. And we wanna keep it in the Docker way, which is like build, ship, and run. So we highlighted throughout the presentation, what's the next 30 minutes going to be about is the failures or the pitfalls that we saw or stumbled upon while working with containers throughout professional work. And we're going to discuss the build part with three pitfalls, the ship part, and the run part. Next slide. And this talk usually have a lot of demos, and we do run them. Jalal decided in the last minute to just capture the slides for the sake of saving time, but there is a repo that you can go to. It's going to be mentioned at the end of the presentation, where basically everything is there. But the demo is mostly using Docker. So we had this initial discussion. If we want to use Docker or other orchestration tools, we could have used Kubernetes, and the same principles applies everywhere. But we decided to stick with Docker for the sake of the presentation. It's, as I mentioned, container orchestration agnostic. It doesn't use Docker Swarm, doesn't use anything. It's mainly containers, but the same principles and the same things that we mentioned throughout the presentation going to applies to all your container orchestration tools. It's CI/CD agnostic, meaning that the demo is not focused on one CI tool, no Jenkins, no GitHub Actions. It's mainly a shell script that you can basically apply to whatever your favorite CI tools. And by sticking to those principles, we aim to make it work everywhere, basically. It's going to be copy, run, adapt, and it's the same principles can be applied everywhere. And the talk is going to be basically a story. And if any resemblance between the stories we're going to tell and real life is purely coincidental. But as in every company, there is a new project that is coming in, and you got the green light to use the technologies that you are happy with. As far as it does the job, you are free to choose whatever technology you want to use, right? And the demo, yeah, exactly. And if you go to the demo, so what we ask you to build is basically an application that shows random words. Whenever it has a database, it has a backend. It's a database, a backend, and a front end. And whenever you refresh the page, you get basically a random words. Deployed in you could be deployed in multiple containers, but we stick with one. If you go to the code, exactly. And the architecture is basically multi-layered. We have the database, which is basically a SQL database that contains a lot of words. We have the words, which is a Java backend, I believe. It's basically connect to the backend, to the database, and read the words, expose a REST API that gets read by small front-end application. And we wanted to run this application in a container. So as any responsible DevOps engineer, we went to Google, typed how we can put a database, front-end application, and a back-end application in a container. And if we check the first results we got, luckily it was a Stack Overflow. So we ignored what the question was. We went straight ahead to the first accepted answer, and we copied the Dockerfile. And that is exactly what we did. So if you go to the code, you're going to find the Docker file. It's exactly the same Docker file. So this is the starting point. And we showed it to the management. They are happy. It's working. It's running. It's working. It's running through some clients. Life is good. And then, as we wanted to scale, as new requests coming in, we started to stumble upon different issues and different pitfalls working with containers. Next slide. And the first one is, as you mentioned, as you noticed, we throw everything into the container. And we developers we want to move fast, and we want to throw everything into the this new unit of deployment, which is container, and that introduced some issues. And we wanted to start understanding how we can solve them. So I am the weird developer that just copied the code from Stack Overflow. Jalal is going to be the expert with his bird, because basically he looks like a good, knowledgeable man. So I throughout this presentation, I will be basically asking him questions, how we can solve those issues. The first one, how we can make the coding sucks less while using containers.
Yeah. First of all, great acknowledgement. You did it right. So first principle, make it right. Sorry, make it work.
Make it work, then make it right. Yeah.
I got ahead. So now we are going to see how to make it right. All right. Second iteration. So I'm going to take inspiration from you guys, developers. You rock. So what do we do when we have code? Mainly, we are trying to make it, to prove that it's good code. So first thing is that we are going to lint it. The linting is the first principle, the first good practice that I'm going to take from your processes and habits and incorporate it in this Dockerfile. So here's my current Dockerfile. It's working, but as we can tell with modern tooling, it's not that optimized. So I'm not going to reinvent the wheel. I'm just letting the community do the work. And one tool in the community, Aboullaite, is really the missing command in Docker native CLI. So we're just feeding this Dockerfile to Aboullaite, and it comes up with really explicit and nice suggestions about what is wrong, what's not that good, what's plainly dangerous in my Dockerfile. So with this, I can fix my Dockerfile, its syntax, and still have the same result, the same outcome, a working application. So here's the new Dockerfile. You see that on the top, I've been merging all the run instructions, okay, all the commands, and not copy-pasting everything from Stack Overflow. I've also been fixing and pinning the versions, which is a very important, as we will see, a very important practice. And also I fixed everything else in terms of syntactic sugar, etc. So now we have a really cleaner Dockerfile for the same outcome. Isn't that great? Oh, last thing. Last thing, I want to just give you the impact. The impact is only one line in your build, ship, run script. You just feed it the Aboullaite command, and you keep on shipping and running just like before. It's really plain easy.
Yeah. So Dockerfile comes with own DSL. It's a new thing that we as developers need to learn, care about best practices. And we as developers are lazy human beings. We like to offload things as much as we can and use leverage tools that makes the work easier for us. And one of those tools is, as Jalal mentioned, is Aboullaite. It's basically a linter for your Dockerfile, introducing a lot of best practices that you can leverage in order to make your Dockerfile more better. And you can basically include it in your CI/CD tool to fail and to have kind of a enterprise-wide or company-wide policy that like have a standard way of having Docker files, and you can even make it as a pre-commit hook. So before even pushing into your central repository, it would fail and make sure that anything that's got pushed into your Git repository would be basically compatible with whatever you have, which is pretty neat.
Good. Next.
So that was fixed. And one of the problems while working with containers is they are hard to validate semantically. You don't know what's inside the container, what dependencies it has, what versions of those dependencies, if the things that's supposed to be there are actually there. And what we do is build the container, spin it up, exec or SSH init manually, even if SSH init is not the right word. But doing that for one time, 10 times, it's maybe good, but doing it for each and every time repeatedly takes a lot of time and energy. So we want a way to validate the correctness of our container semantically.
Yes, very quickly, still working my way to making the container clean. I'm going to specify what is clean for me. I don't want some things, some packages, some behaviors, some configurations. So I'm going to assert and explicitly forbid these configurations. So I'm going to use YAML again, our worst friend. And I'm going to use a tool, an open source tool called Container Structure Tests. It's also missing in the Docker native commands, but it's very, very important that we assert the content of the Docker image. And I can do any sort of rules, regex, and test on metadata. This is very, very easy. You can see that tests are very fast, under a second. So I can put it in the post-build stage. And again, the impact on my tooling and my script is one-liner. So here I just put it as a Docker image, because you can test Docker images by using Docker socket. So very easy and very, very useful as developers give us their feedback. They are very happy. Right, Mohammed?
Yeah. So Container Structure Test is an open source project from Google. It basically does what we want it to do. It's basically assert that the content that we want is actually there. And by content, I mean files, directories, executables, specific versions of those executables. And it basically, as any testing system, it would fail if one of those fail. And it's a good thing to include it in your CI pipeline to make sure that the container that you're building is semantically correct, which adds a layer of confidence into your build pipeline. And again, you can run it as a pre-commit to make sure that nothing goes to your Git repository before it's actually valid. One of the trade-offs of using containers is you can download the internet, basically. You can build an image that is a few megs or build an image that is a few hundreds of gigs. It depends on the way you basically structure your Dockerfile. And we as developers, we are not experts in the way how Docker technologies or Docker build or layers system it's called. And we turned out to Djalal into understanding how we can speed up basically the build process and making it faster.
Yes, Docker from day one has been coded and released to be very aggressive on caching. So everything that it does, it doesn't want to do it twice. So how does the layering works? Essentially is each line in your Dockerfile is a layer. So depending on how you order these lines and what you do, especially the copy instruction, you can invalidate and lose the benefit of caching. So here I'm going to focus on this stage where I'm copying all the code source from the Java component words, and I'm in the same command mvn verify. I'm resolving external dependencies. So it's a big layer. I'm using here the dive command line. If you don't know dive, you should really use it on a day-to-day basis. This has saved our lives many times. It's an introspection tool for Docker images. It tells you what has been added, modified, deleted by layer and by command. So I know there is a problem here, because each time I change this Java file, I'm again downloading everything from the internet. So I fixed it for you. And I just split this copy into 2 steps, okay? First, the first step is going to resolve the external dependencies and put it in a cache forever. As long as my POM XML doesn't change, it's cached. So the whatever delay, 1 minute, 2 minutes, 3 minutes, it's a bonus for us. It doesn't exist anymore. And I'm going to use another copy for my source code, the one that is really changing a lot more often. All right. So I think now that we can see that my build is now under 2 seconds, 1 second and something. So this is very different from the 1 minute from before.
Yeah, you didn't show them 1 minute from before, but that's fine.
Sorry.
No worries.
And I can show you the dive result where my layer is now 3 megabyte, for approximately 4 megabyte, where it was like 20 or 30 megabytes. That I didn't show also.
Yeah, I know. You get rushed. Anyway, so understanding the concepts of layers and caching in Docker, it's fundamental in the way we want to how we want to structure our Docker file. And basically, for example, Java and any compiled language, we want to put the files that are more likely to change in the bottom of your Docker file, and the files that are less likely to change, such as dependencies and static resources, in the top of your Docker file. So those files are basically cached for your next build, and that would help to speed up your build process. So you're not building the whole stack, you're basically only building the layers that is changed. And we're gonna mention it in the end. There are some tools that leverage that as well. And the example, I mean, the last example is to say that the files that are less likely to change, the OS, the system packages, your dependencies, and then the files that keep the things that are more likely to change, such as your code, which is changed frequently each and every time, in the bottom of your Docker file.
Yep.
Okay, so that's some of the issues that we faced in the build phase, right? So developers are happy, and as now we fixed them, we wanted to move into the ship phase. Right? So we want to ship our container, we still have one container for now, or our container into somewhere to save it and reuse it. However, there is this, in cloud native world, and even the 12-factor apps mentioned that the artifacts that we build needs to be as much as possible ISO production. We need to have similar artifacts in development, in production, and whatever environment you have in between. And we as developers know that it's hard to have, because production, you want to have as less components and less dependencies as possible, because you don't want to keep tracking security bugs. However, in development, you want to have as much debugging tools, as much other dependencies, to have a better overview and understanding of the system. So how we can basically solve this trade-off and this inconsistency as it's appearing in the first hand?
Yeah, it's a conundrum. How do I do to make my to work on a day-to-day basis where I only should have one version that is ISO production? So I'm going to use a technique in the Docker native Dockerfile format called multi layers. So multi-stages. Sorry,
multi-stages.
Yeah, in this multi-stages feature, I'm going to define like variants of my Docker image. One variant will be always, the last one will be the prod one that is labeled here as production, okay? But I can have also a developer variant, a staging variant, and each one has its own tooling, its own debugging components, and this is really easy to do because we just have to maintain the same Dockerfile, and in the same Dockerfile, I just start a new variant by reusing the instruction that is from da 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 da, and then we just in and we just mention it in the last in our script, and by default my Docker images will be built by for production, which is much more optimized because it doesn't have many of the tooling that Mohammed mentioned, package manager, compiler, and all the sort of things that we use in development or in staging, but we don't want and we don't need them in production.
Yeah. So before multi-stage builds, what we used to have is a Dockerfile per environment. We have Dockerfile dev, Dockerfile prod, Dockerfile God knows what. So multi-stage builds, and it has goals. As Jalal mentioned, it basically helps to build and target whatever environment you want to have and tweak it depending on your preference. And that will enable to have one Dockerfile to track all your or to build all your containers, but have different targets and different containers depending on what the environment that you want to deploy to. What we call environment profiles. Secrets, and secrets needs probably a session on its own, but when we work with real applications, we would need to database secrets or database passwords. We need service accounts. We need certificates. We need SSH maybe to access some other servers, and those can be mishandled easily with the container word. Should we put them in the containers? Should we not? What's the practices that you recommend here?
Yeah, always in the same track that we need to keep our containers clean from secrets and credentials. So here is an innocent file that has been copy-pasted by the innocent developer, and in the innocent Dockerfile, in this same line here at the bottom, I don't know if you see, it gets copied into the Docker image. So no one is aware and no one is gonna detect it unless we use the tooling. So one of the main tooling is to use a secret scanner. The secret scanning field now is booming. There are many alternatives. One that is hosted and free is GitGuardian, but you can look for Git leaks or Etsy secrets. There are many of them. So look at the results. It stopped the build and telling us that, oh, you maybe have a problem in production if you ship this because I see what you did. So we are just one line to make our Docker image, one line away to make our Docker image cleaner and more secure. It's just to invoke the GitGuardian secret scanning tool. So the other recommendation is to use secrets as they should be. They should be encrypted and they should be provided by the orchestrator or by a secret manager vault like Vault or your public cloud provider secret management service, and never be included inside the Docker image or as an environment variable. Those days are gone.
Yeah. So basically leveraging tools that does the scanning to detect any leakage in password, sensitive files, and also leveraging the platform native secret tool. One thing that I wanted to add is we mentioned the concept of layers in Docker, and there is no delete in the Docker. The container word, meaning that if you included a secret in one previous layer and they deleted it in the second one, a malicious user can still get into the content of the previous layer and using simply dive, as Jalal mentioned, and you can go back and check that secret file. So better to not have it at least in your container. Tags. So it's easy to override tags within the container world. And that's one of the things that is problematic, especially if you are within the container world. I think there's even, especially the overuse of the latest. It's easy, it's convenient. However, it should be avoided as much as possible. And in the cloud native world, there is an incentive or a recommendation basically to have one-to-one mapping. So each version, as anything in software engineering, I believe, needs to have its own and proper tag. However, containers doesn't enforce it by default, so you can override tags, and that could introduce a hell lot of problems. So what are the best practices from your point of view using tags?
Exactly. So first thing that Mohammed mentioned is that for once, Docker didn't do well in their native settings. The tag feature is really riddled. They use latest by default, and they are mutable. That means that version 1 today can be another version 1 tomorrow. We don't want this. We want something that closer to Git, where each version is uniquely identified by a commit or a SHA, as we know. So this is one thing. So you have to pick a versioning strategy or versioning scheme. This is on us. Second thing is that when we ship a Docker image, we have the whole ownership, and the Docker image is like an iceberg. So you have your app. That's what you see, but you have a whole lot of guests that are coming also and running in production. So who are they? Oh, what version is it? Is it obsolete? Is it too much? You don't know, except if you leverage the Docker sbom command. So this command, Docker sbom, it will...
What is an sbom?
Yeah. It's a really good question. Thanks. It will build what we call a software bill of materials. That's like the ingredients of your recipe. So you're cooking something. What are the ingredients? That's the SBOM for Docker image. And you have many, many ingredients to run your Docker container in deployment. So what I'm doing here, what my recommendation as an 8-year Docker user is to collect for each deployment the SBOM one-liner and store it somewhere. You can store it on a platform, you can store it on a dedicated tool, or you can store it in the Git repository, another one, not the one for the code, and really track which version has been deployed with which SBOM, and then also use a versioning scheme. This one is based on the date, but you should you will certainly come up with a better versioning scheme. And this is very important to make our Docker images clear, to see what is inside them.
Yeah, you probably heard a lot of talk about supply chain, and SBOM would definitely come up. Like it's one of the things that is gaining a lot of attention lately, and software bill of materials is becoming more and more introduced and used within the security world and the DevSecOps movement. So leveraging SBOMs is really good to understand what dependencies, at what version are used, and to secure your supply chain. And then this is dependent on the preference and how you want to what strategy to use to version your Docker containers. However, yeah, it depends on your preference. We forgot to mention that Docker have though the SHA, which is like, even if your latest, even if we override, we still can have it using a specific SHA, but that's got overridden basically, and could be easily misused.
Yeah. It's hidden. Yeah. Okay.
So yeah, that's all for the run and ship part. Shipping. Yeah. How are we doing in terms of time?
3 minutes.
3 minutes. Okay. So we're gonna run. How about running it in production, basically? And when we're talking about running it in production, health checks come to mind, which is basically making sure that your app is ready before it's actually starting to receive traffic. However, leveraging health check can introduce health check issues, especially if they are misused and you're bombarding your application while trying to spin up and start with a lot of health checks, especially if they are misused. How we can leverage and have better practices.
Yeah, this one is really for SREs, if there are some in the room, I guess so. You have to take your observability stack and pass all kind of metrics on your Docker containers and come up with these 3 values. The first one is the interval of the health check. Hammering a health check once a second is not really doable. Timeouts. If one timeout for an health check is a fail, 3 fails and you're out. The container will restart and will be recreated, so it's a false positive. Also, the start period is how much time do my container need before being ready to be checked for its health. So these values, you include them by looking at your tests, looking at your observability stack metrics, and you obviously it's an iteration. So you have this nifty instruction in Dockerfile, the health check. Yeah. So you can see that even if you inspect the containers, they will tell you what's happening with the health checks and if it's healthy or not, etc. So you have all the feedback loop that we need.
Yeah, and Kubernetes specifically excels in that. It has 3, I think, health check probes, like liveness probe, readiness probe, and startup probe, and each one of them is used for specific context. But it's really good to leverage them to improve the health check of your application. And for the metrics to use, there is no right or wrong answer here. You need to look for the metrics and how long your application take to set up those metrics or data. And up until now, I know this was painful to have one Docker file. You probably know about split one process per container. So and we're leveraging one container for all our databases. So it's time to split it up, and we want to scale. So we want to scale our front-end application to have a lot of users, a little bit of the back-end. So how we can basically split that.
Yeah, that's the problem. Problem is that you are coupling everything together. That's not a good practice at all. So now that we have the traction and the need, we can split everything. So here I have the previous Docker file. Everything is in here: the Java, the static, even the database. God forbid.
And it works fine. Nobody knows.
You made it work. That's great. Now we are going to make it clear after we made it clean. So to make it clear, we are splitting our containers by scope. So you have the front end and the back end and the DB. Everything now is separated in its own folder, in its own Docker file, and with the same amount of quality. You have the test with container structure test, you have the linting with header lint, you have the multi-stage when you need it. So everything is still on top-notch quality, but now it's decoupled and it can scale independently. So here, for instance, I put 3 replicas on the words because it's Java. No, I don't know. And only 1 because it's Go. And the impact on the build ship run script is really comfortable because I just used a Docker Compose build to build everything and a Docker Compose push to push everything, and I'm only using Docker stack deploy to deploy based on 1 YAML file. So it's very concise, very not verbose at all, and it does the job with the best practices. Yes, it's replicated.
Yeah, this is more of an architectural decision on the way you want to split your application and what the scope and what the responsibility of each container would be. But yeah, having more focused applications improve the availability and maintainability of your application, obviously. Moving on, because we're running out of time. The last one in the run phase is the security. And now that we are running into production, we want to leverage basically the tools and the dependencies that we use, how we can constantly be monitoring our application, monitoring our production environment, and instead of being on the reaction phase, we want to be ahead of anything that could happen.
Yeah, picture yourself now that the nosebleed vulnerability has been disclosed, and the CTO comes down and say, "Hey, are we impacted or not? How do you prove that? How do you protect yourself?" So in this principle and this track that I need to make my containers clear to see that and to prove that they are protected, I need to leverage the CVEs databases and scan them, scan my artifacts. So for this, I'm going to use the Docker Scout CVEs command, previously Docker scan, and I'm going to prove that there is no critical, no high vulnerability. See, I have the severity filter. And then I'm going to go one step further. I'm going to sign the image. So by signing the image, I'm proving on the other part that's on the other side, that is production, I'm proving that this Docker image is coming from us, is coming from our organization. And I can go one step further and block any non-signed image from production to run. With this Docker Content Trust, with this feature, we cannot run non-signed image on the production anymore. So this, the scanning and the signing, that makes your containers clean and clear and strong. See, here's an example of the signing where you can have many signers. It can be QA, it can be production, the product manager, the release manager. And here's an example of a pull. I tried to pull traffic. This is a public official image, and it failed because it has no valid trust. It has no signature. Same thing for Aboullaite.
Yeah, I think you covered it well. Next. Yep. Happy? We're all next. Yeah, the last one we want to mention is you probably don't even need Dockerfile. So sorry, you bear with us for the past 30 minutes and then you don't even need it. Like there are multi-tools. Containers have changed the way we actually ship our application, that there are dozens of tools out there that help you build your containers with best practices in mind, all what we have mentioned. If you don't have to stick with Dockerfile, then probably that's something you might want to look at. And we will give an example with Jib, which is basically a Java plugin or a Maven and or a Gradle plugin that you can basically introduce in your favorite Java build tool. Here we have used Maven, and we can use it basically to build our Docker container without even the need of having a Dockerfile, to basically have all the things that we mentioned and the layering, best practices, and so on and so forth. Yeah, and it's smaller in size because it's leveraged, and it basically splits the layers into three: the resources or the dependencies, the resources, and then the code in the end. Yeah, and that basically sums it up. Sorry for running out of time.
Thank you. Any question? Challenge? Yeah, I made it, how do you say? Yeah, I didn't mention some of the Dockerfails. So if you come up with more Dockerfails, I would like to hear from you because there are many more.